Okay, on this lesson we're going to talk about irrational numbers. I'll do a little bit of a recall of when we discussed rational. Oh look, it's already up here. All fractions are rational. I know you'll hear me say that a lot. But, talk about rational. There's two types of numbers. There's rational numbers, and then there's irrational numbers. Now, rational we know are repeating decimals or terminating decimals. Okay? This is when a number goes on, this is when a number stops. Now today we are going to learn about irrational numbers, and hopefully we'll be able to fill something in about up under this column after the end of this lesson. Going on into the lesson, we'll be covering some examples. Okay, a number that is the square of an integer is a perfect square. Guys, basically that's just talking about, we know that the square root of 4 is 2. Okay, the square root of a number, this is square root of a number is another number that when multiplied by itself equals the original number. That's the same thing. 2 times 2 equals 4. Some square roots are rational, and some are irrational. Irrational means, guys, this sentence right here is all it's stating is an irrational number cannot be written as a fraction. Okay. Some common terms. We know this is square root symbol. Square root of 9 is 3. Rational square root. That's our perfect squares. That's 4, 16, 25. That's the whole numbers multiplied by itself. Irrational square root. Okay, so I'm going to come back here. What this means, guys, if you have the whole numbers 1, 2, 3, 4, 5, so on, okay? The square root of 1 equals 1. The square root of 4 equals 2. The square root of 9 equals 3. The square root of 16 equals 4. And the square root of 25 equals 5. So these are basically the same numbers, guys. But when we're getting into all this that I just wrote, all this is rational, okay? These perfect squares are rational because they end up being terminating decimals. But now when we look at irrational, if I take a number that's square root of 1 between square root of 1 and square root of 4, let's just say square root of 3. There is the two numbers, if you would type that in your calculator, square root of 3, by the way, you might want to make sure you have a scientific calculator. You get a decimal. This is what my calculator tells me. 1.732050808, and it's at now at the end of the calculator. That number has no pattern, no repeating decimal, and it never terminates. It goes on and on forever. So basically, guys, when you have a square root of a number that is not a perfect square, it will always be irrational. Okay, let's get into some examples. Okay, determine if each square root is rational or irrational. Once again, guys, this is not a perfect square. 2 times 2, see, look, 1 squared equals 1, 2 squared equals 4. That is not a perfect square. So this will be irrational. Square root of 7. There's some kind of write these at the top. Maybe that'll help us. So, I'll do it to the side. Square root of 1 equals 1. Square root of 4 equals 2. Square root of 9 equals 3. Square root of 16 equals 4. Square root of 25 equals 5. Square root of 36 equals 6. only perfect squares. If there is not a number that falls into these perfect squares, it is known to be irrational. So square root of 7, that is not on our rational list. Square root of 4. Square root of 4 is 2, that's rational. Square root of 9, which simplifies to 3, which is also rational. Square root of 8, that is not a perfect square, so that is irrational. Square root of 2, not a perfect square, rational. Square root of 5, not a perfect square, irrational. Square root of 6, not a perfect square, irrational. And we're finished, okay? The only two rational perfect squares we have is 4 and 9. Okay, so we're going to keep this up, stand up. So, which numbers are irrational? That's the square roots of non-perfect squares, okay? Well, I know the square root of 25, I know that equals 5. Okay, but the square root of 50, that is not one of my perfect squares. Square root of 49 is. So the square root of 50 is actually a long decimal. I'll bring it down. 7.071067812, and then it stops on the calculator. But it stops on the calculator because it runs out of spaces. This number has no pattern, no repeating decimal, and it goes on and on forever and ever. Therefore, this is irrational. An irrational number means it goes on forever and ever without a repeating decimal. Okay? 125. Now, I look at 25 and I think, oh, that could possibly be a perfect square because I have the number 25 in it. But no, guys, if you put 125 in your calculator, the actual decimal for this is 11.1, and it goes on and on without a pattern, without repeating itself. Okay? So which numbers are irrational? The two irrational numbers here would be 2 and 3. Moving on to part 2. Most common irrational number. When you see pi, you know it's automatically irrational. We use 3.14 to represent pi, but it's not the actual number for pi. As you can see, the pi number goes on and on and on forever and ever and does not terminate or repeat. So we're going to go on to some examples of this irrational. Okay, so 2.125. Guys, if you can see, that number does not go on and on forever because it does not have dots extending. This is a terminating decimal. It terminates into zeros. Although the zeros aren't there, it's understood to terminate into zeros. So when we have a terminating decimal, we know that's rational. 2.111, well, yes, this does continue. It keeps on going, but guys, it's repeating. How do I know it's repeating? Because there's not another number. Although it doesn't have the bar on top, there's not another number within those 4 that's different from 1. So this is a repeating decimal, and we know that rational is repeating and terminating. Okay, so this is rational. C is a really little tricky, okay? Let's look at it though. 2.01 repeating decimal. There's nothing you could go across and put a bar over that would hold true, okay? If I went and put a bar over 0, 1, that means that would repeat 0, 1, 0, 1, 0, 1, and it's not doing that, okay? This is not a repeating number. It is not a terminating number. It's a number that goes on and on and on that never repeats itself. So therefore, this is an irrational number. Does not repeat, does not terminate. Let me make that note. Irrational. Does not repeat, does not terminate. Okay, so going on, D, 2.1, 2, 3, 4, 1, 2, 3, 4. Here we have a repeating decimal, rational. 8, 0, 3, 3, 3. Our 3 is repeating, okay? 3 in a row and the dots after, 3 is repeating. We have a rational number. You could come here and write this just on E. This is the same thing as 1.803 repeating. Which number is not irrational? So basically saying which number is not irrational, so it's saying which number is rational. We're coming through here and wanting to look for which number is rational. Okay? Rational also means repeating or terminating. We're coming through and we're trying to find what is repeating or what's terminating. Well, none of these are terminating. Okay? So we're just looking for what is repeating. 2, 0, 2, 0, 0. Well, we can stop here, guys. There's nothing repeating. It's adding a 0 each time, but that's not a repeating decimal. So 1 is not rational. 3.213, 213, 213. Here we have that 213 is repeating itself all the way to 3. I could rewrite 2, this number, as 3.213 with the bar across the 2, the 1, and the 3. Now let's just check 3 because it could be more than one answer. So we know that 2 is rational. It's a repeating rational number. Now going on to 3. 3.12, 122, 1222. Once again, guys, they're adding a 2 each time, but that's not repeating. So 1 and 3 is irrational, but the question is asking which number is not irrational, which would be 2. This is natural, guys. This is when you're first born as a baby. It's natural for you to start off counting 1, 2, 3, 4, 5. That's what I tell my kids in class. As a baby, you don't learn to say 0 first. You don't start saying 0, 1, 2, 3. Or you don't start counting 10, 11, 12. You always start with 1, 2, 3. It was just natural for us. So whole numbers, guys, the only difference between natural and whole is whole begins with 0. So if I was to tell you, make a list of whole numbers, this is what they would be. 0, 1, 2, 3, 4, okay, and so on. All the way into infinity. Whole, think of whole as a whole, looks like the 0. and then the negatives of these whole and natural.
So all the whole numbers and the natural numbers are integers.
But this does not mean decimals. Make sure we realize it's only the whole and the natural numbers and its opposites.
Irrational numbers are the set of all numbers that can be written in the form a divided by b.
Rational numbers are all numbers that can be written as a fraction. Okay, here we go. Natural. Was it natural for us to start counting at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15? Yes, it was. That's a natural number. Okay, is it a whole number? Yes. Whole is 0 to infinity. It's a whole number. Is it an integer? Yes. An integer is whole number, natural number, and its opposites. It is an integer. Is it rational? Yes. It can be written as a fraction. 30 divided by 2 equals what? 15. It is a rational number. It also is a rational number for the reason that it's a terminating decimal. Terminating decimal. It is rational. Guys, if it is rational, there's no way that it can be irrational. It's not possible. All numbers are real. All numbers are real. Okay. Natural number. No way, Jose. There's no way it's natural for us to understand negatives. Okay? Is it a whole number? No, because it's less than 0. The first type of whole number is 0, 1, 2, 3. Is this an integer? No. Just because it's negative, it doesn't mean it's an integer, okay? It would still have to be an integer and a whole number. Is it a rational? Absolutely. It's a terminating decimal. If it's rational, there's no way it's irrational, and all numbers are real. Square root of 45. Let's put that in our calculator. That is 6.708203932, and it cuts off from the calculator. There's no pattern. There's no repeating decimal, and it does not terminate. Therefore, this is a irrational number. But all numbers are real. Moving on to this last one. The next. 121 divided by 35. We have another long decimal. Here we have 3.457142857. Once again, we have no repeating decimal, and it does not terminate. It stops because it's the end of the calculator, but it does not terminate. Therefore, this is not a whole number. It's not natural for us to understand decimals as a baby. It's not a whole number, because the only difference between whole and natural is that it could be 0. It's not an integer. It's not rational because it does not terminate or repeat. It's irrational, and all numbers are real. Okay, this negative is only outside of the 16. Now guys, if this had a negative 16 inside, this would be an imaginary number. It would not be able to be possible. But this negative is on the outside. This is the same thing as negative 1 times the square root of 16. Okay? So I know the square root of 16 is a perfect square, which is 4. I bring down what I have in front, which is negative 1 times 4, which is the same thing as negative 4. So basically, I'm trying to figure out, is negative 4 a natural number? No, natural is 1, 2, 3, 4. Not natural, not whole. It is an integer. It is an integer. Rational, absolutely. It's a terminating decimal. If it's rational, there's no way it's irrational, and all numbers are real. Okay, this last one, 21 divided by 3. If you simplify that, guys, that's just equal to 7. Okay? 7 is a natural number. It is a whole number. It is an integer. It is rational because it's terminating, and all numbers are real. That was a lot, okay? If you need to, you can either go back and Google and get a list. Make yourself a list in natural whole integers and write it a couple of times, and you will not be able to forget that. What are all the possible names for 1 and 2 ninths? Okay, so here we have a mixed number. Mixed because we have a whole and a fraction. There's a couple ways you could do this. Honestly, I'm going to go ahead and turn this mixed number into an improper fraction, which would be the same thing as 9 times 1, which is 9, plus 2, which is 11, and you put it over your denominator. These are the two exact same numbers. That's how I would first look at it. Well, then I'm going to simplify 11 over 9. When I type that in my calculator, 11 over 9, that's going to be 1.222, and it goes on and on and on. So that's 1.2 repeating. What I'm going to be able to classify this is as a rational number and a real number, because all numbers are real. It's rational because it is repeating. Okay? Rational number and real. All rational numbers are real. Good. Right, so that closes up the actual examples. I will bring up this closing check in case you want to do any practice problems. And just like the last video, I'll pull up the questions. You can pause it. I won't keep it on. You can pause it, and in just a moment, I'll show you the answers. Here are the questions. Just pause whenever you need to. And now I will give you the answers. So this is just going to be a little extra practice for you. And that will complete discussing about rational and irrational, giving you the brief definition of rational and irrational numbers.